Now, we are going to figure out the answer for this triple integral so we can figure out the volume for this thing here. However, do not just integrate this as how it is, because soon we'll have to integrate this thing in the y world, and that we would have to use the integration by trig substitution. It's doable, but don't do it. Instead, if you look at this right here real quick, this right here should remind you of the polar coordinates. Like x squared plus y squared is equal to r squared, that thing, right? However, the 9 is a little bit annoying. But it's okay, because we can just do the following. Look at this as 3x and then squared, and then the rest stays the same. Here's the deal. I'm going to call this to be a new variable, u. And now notice I'm just using one new variable, the u. I don't have to do the Jacobian matrix thing. All I have to do is differentiate and then solve for dx. dx is 1/3 du. Now, all I have to do is replace this with 1/3 du, and we will have this integral to look at. And then dy dz. I'm not going to figure out these right here because that's not the main part. I would need to do the polar coordinates next for u and y. It's just like the x and y, but like we are using u in here because of the 3x here. So, ladies and gentlemen, if you take a look right here, this equation or inequality will give us u squared plus y squared is less than or equal to z, and I will just do the usual business. Put u to be like the x component, r cosine theta, and y is still the y component, r sine theta, and then we see the u squared plus y squared. Square this plus square of that, factor out the r squared. Cosine squared plus sine squared is equal to 1, so we have that. So that's that. But now, more importantly, we will have to get this right here, aka the differential. Imagine when you have dx dy, once you get to the polar world, what do you need? It's not just dr d theta. Let's have a look at my sweatshirt. There is that extra r, okay? So, this right here, we will just get r dr d theta. The notation stays the same because I'm using r and theta here. And then, here we still have that 1/3. And, ladies and gentlemen, we are going to figure out the limits of integrations for r, theta, and z. Let's do r first. Right here, you see that we have u squared plus y squared is less than or equal to z, and that's equal to r squared here. So r squared must be less than or equal to z. Take the square roots on both sides. We get r is in between of negative square root of z and positive square root of z. However, we can make r non-negative, so I'm just going to not look at this and put a 0 instead. I want to have r going from 0 to square root of z. That's okay, because theta, we are having one full revolution. All I need is going from 0 to 2 pi. Here's a small question for you. What if you did use square root of z but negative right here and up to z? In that case, what theta do you have to use? You can leave a comment down below and let me know. And then finally, to finish this up, for the z, the bottom value here is 0 up to 4, so 0 to 4. Have a look. Isn't this integral much more friendlier compared to the original one right here? Yeah, so now we just have to finish this and then we'll be done. Here we go. Do this part first. We will have r squared and then divided by 2. So that will be 1/6. Put it all the way on the outside. And these two integrals stay the same. 0 to 4, 0 to 2 pi. And we will have r squared going from 0 to square root of z. This part though, when we plug in square root of z, square root cancel, and then plugging 0 doesn't matter, we will just have z. Now, The inner part, we have z in the theta world. It's just like a constant. I can put this on the outside here. And then I'm just going to separate the two integrals. I think it's easier. So all the way in the front, that is still 1/6. And then I will have integral going from 0 to 4. I can put down the z first. And then do this. dz. And then multiply by the integral going from 0 to 2 pi. And then just the theta. Okay? Now figure each part out. This is 1/6. Do this in your head. That's z squared over 2. Plugging 4 into it is 16/2, which is 8. And then lastly, this part is just 2 pi. Now, ladies and gentlemen, cancel and multiply. We get 8 pi over 3. That's it.